Hi, my name is Jun-Ho Choi, and I am a PhD student in Yonsei University in Korea. I would like to introduce our paper named SRZoo, an integrated repository for super resolution using deep learning. Recently, there have been proposed various deep learning-based image processing algorithms. It is powered by massively enhanced computing environments in terms of both hardware and software, where graphics processing units, or GPUs, and various open-source versatile deep learning frameworks like TensorFlow and PyTorch enable accelerated computing. When making a new image processing algorithm, it is necessary to compare its performance with that of the other state-of-the-art algorithms to find out its improvement. To do this, it is necessary to run the image processing algorithms in the same environment and use the same criteria to make a fair comparison. However, we find that such a fair comparison is not well employed for enhancement models, especially for super resolution or SR models. Note that SR is a task to generate a high resolution version of a low resolution image, which is one of the widely used image enhancement techniques in recent years. We find that there are two main reasons. First, there are various SR models implemented in different deep learning frameworks, such as GAFE, PyTorch, TensorFlow, Keras, and so on. Since each framework has its own implementation, it is hard to evaluate the performance of the SR models in the same computing environment in terms of both hardware and software for a fair comparison. For the image classification and detection tasks, there exist integrated repositories that provide classification models on a single deep learning framework, such as Keras application. It provides various deep image classification models with their pre-trained weights, so it is possible to employ the models in the same environment. Second, SR models have been evaluated with different evaluation criteria. In the classification tasks, there are many straightforward and clearly defined evaluation criteria, such as TARP and error. However, in the SR task, it is hard to make concrete standard evaluation criteria due to the various configurations and evaluation methods. This table compares the conditions used for evaluating popular SR methods. As shown in the table, many SR methods use different criteria in terms of color space, shaping edges, image precision, employing geometric self-ensemble technique, and so on. So, motivated by these observations, we decide to develop an integrated repository for deep image SR models, which is called SRZoo. It provides various state-of-the-art pre-trained models that are ready to be deployed and additional useful tools for evaluating performance with the same evaluation criteria. Thanks to its flexible constructed structure, it enables supporting various applications such as platform-agnostic image enhancement. Now, let me introduce the key features of SRZoo. The first key feature is the model conversion. SRZoo provides converting SR models to be compatible with tools in SRZoo. It already bundles 29 pre-trained models that are converted by our model conversion tool. This includes EDSR, EUSR, DBPN, RCN, MSRN, ESRGAN, CRN, FRSR, and so on. With the converted models, it is possible to easily obtain super resolved images by a simple command as shown. You can also change the parameters such as upscaling factor and output destination. It is also possible to use our model conversion tool to convert other SR models that are not included in our repository. We provide documentations and code snippets that can be injected to the implementation of target SR model to be converted, and it supports various deep learning frameworks such as TensorFlow, Keras, and PyTorch. SRZoo also supports various model configurations for the SR tasks. For instance, SRZoo supports various upscaling factors such as 2x, 4x, and 8x. In addition, it supports the geometric self-ensemble method, which is widely used for performance boosting method during test of the SR models. Therefore, it is possible to apply the method to the SR models that do not employ it originally. It is also possible to change the inference devices, such as CPUs and GPUs. Finally, SRZoo provides performance evaluation on various metrics. We find that many SR methods implemented in deep learning frameworks, rather than MATLAB, are evaluated with MATLAB-based codes. Since SRZoo provides Python-based evaluation codes, it is possible to measure the performance in one place and compare them more equitably than before. SRZoo currently supports 3 popular evaluation metrics, including PSNR, SSIM, and NIQE. Now let me show you the demonstration of using SRZoo by employing performance comparison. We compare some selected SR models included in SRZoo on 100 images in the BSD100 dataset. Note that BSD100 dataset is one of the most widely used benchmark dataset for SR models. We employ 2 inference devices, which are a CPU and a GPU. We also evaluate with following evaluation metrics, which are PSNR, SSIM, NIQE, and running time on CPU and GPU. Here are the results. Note that the models annotated with plus, such as EUSL plus, EDSL plus, and RCAN plus, are the models employing geometric self-ensemble method. We also show the quality metrics that are reported from the original papers of the compared models. This shows that with SRZoo, it is possible to evaluate the models with metrics that are not used in the original papers, including NIQE and running time. It is also shown that there are some differences between the originally reported and metrics measured by SRZoo. For instance, the performance measured by SRZoo shows that RRDB is slightly better than RCAN+, while each original paper reported the same PSNR values and SSIM values. This justifies the necessity of SRZoo for a fair comparison of the models with the same criteria. This figure compares the SR models with respect to PSNR and NIQE values. It shows that there is no significant correlation between PSNR and NIQE values. However, it shows that employing geometric self-ensemble is harmful to perceptual quality, even though it is beneficial to reduce the distortion. This figure compares the SR models with respect to PSNR values and running time. It shows that geometric self-ensemble method dramatically increases the running time. Finally, we employ the geometric self-ensemble method on RRDB, where the original implementation of RRDB does not employ the self-ensemble method. This model shows the best performance in terms of PSNR and SSIM values, and it proves that SRZoo can boost the performance of the existing SR models. Also, these results demonstrate that SRZoo enables a comprehensive analysis of the performance. Now, let me explain the possible applications of SRZoo. First, SRZoo provides pre-trained SR models in ready-for-deployment conditions. For various SR applications, SRZoo allows obtaining super-resolved images regardless of the specific platforms. For example, it is possible to deploy SR models on the mobile platform via TensorFlow Lite or web platform via TensorFlow.js. So this figure shows example output of the SR models running on a desktop web browser and a mobile web browser. Second, SRZoo enables employing SR models as a part of other image processing tasks. For example, SR can be used as a pre-processing tool to enhance the performance of other image-related tasks like object detection and image captioning. Also, the provided SR models can be used to thoroughly analyze their intermediate processes by computing the features and gradients. Third, SRZoo can be easily extended to other image processing tasks thanks to a well-structured architecture. Since SRZoo is developed to deal with models considering images as both inputs and outputs, it can be used to employ the other image processing algorithms like image deblurring, style transfer, and image compression with only a few modifications. As a proof of concept, we provide a pre-trained deep image compression model in SRZoo. So, SRZoo is currently available on GitHub. You can find our repository on the following link. Also, you can find the software, documentation, and pre-trained models. Thank you for your attention.